So I think we're going to start. It's just a few minutes after 1:20. I don't have a clicker, so I'll be standing behind this podium, I guess. But I hope to make this a bit more interactive rather than me just standing behind a pulpit and lecturing anybody here. As I was just taking a photo with Bruno, and it's awesome to have people who've been working in this space for decades now. So here today, I'm representing Nitro. I'm the CTO at Nitro. My name is Tiho. I'm assuming that everybody's fairly familiar with Nitro, and you guys have used our Nitro Pro or Nitro Reader on your desktop, or maybe Nitro Cloud on your browser. Nitro's been around for 10 years, and we started originally as a PDF creator, as a PDF editor as well, and we've enhanced our feature offering, and we've moved across the spectrum into various parts of dealing with PDF, including on the desktop, in the browser, on mobile. So today I'm going to try to spark your imagination. And today I'm going to talk about what it might look like to understand PDF really at web scale. And when I mean web scale, I mean like understand all of the PDFs that are out there, or PDFs that some of the largest enterprises, the volume of the PDFs that largest enterprises have to be dealing with. This is meant to be a bit inspirational, as well as there are some things here which we potentially are doing right now at Nitro, but I'm not trying to be prescriptive at all. I'm just trying to actually spark a conversation. So if anybody has any questions while I'm actually talking, that would be great. And which way is it? Great. So to kick it off, just a really brief slide about reminding everybody where we are actually. Today we're at Adobe. 22 years ago, PDF was created as a standard for self-contained, complete, fixed layout, flat document. It was meant to inspire or help with pixel-perfect environment-independent reproduction of business documents, or any documents for that matter. But it was actually before internet really took off, and before HTML as a document format on the internet took off. And so this presentation really is about kind of those two and how they evolved, and what we currently potentially do with HTML and how we understand it at web scale, and what we could be doing with PDF to understand it at web scale. And there's a question mark in there because there were a couple of really great presentations here already about handling fonts and missing glyphs and all of the things that you might do. So actually PDF versus PDFA, there are a lot of really, really technical, great details, which all of us in this room have, I think, worked through in detail. All right. So this is, Mark Andreessen's kind of software is eating the world. PDF is eating the world. We all know that. That's why we're here, I believe. If you just Google file type for PDF, you get about 1.5 billion, I think I got last night, PDFs. And when you look at other XLS or PowerPoint or anything like that, about 80% of file office formats are PDF. Last year, we ran a survey with our user base together with PDF Association. We also looked at our own customers, and our own customers are reporting similar numbers for their business documents, their office business documents, meaning about 80% of the documents that they work with are in PDF format rather than Word, Excel, PowerPoint, and so forth. And what's especially troublesome is that because if you work at a business and of any kind, you're likely working a lot with people outside of that business, and so the typical format of exchange, business document exchange, is the PDF, and usually the means of which that is being exchanged is still an attachment of sorts, and we still haven't really moved really far with PDF productivity as you will. Keep switching the wrong one. And so 22 years later, PDF productivity, while there are many, many powerful things you can do with it, and while there are many powerful services and APIs and SDKs out there, some of which are being presented here these 2 days, PDF productivity, PDF productivity nirvana, if you will, is still not a commonplace. We know that because if you look at Forrester research, you know that a vast percentage of PDFs are still getting wet signed rather than digitally signed or e-signed. We know that most browsers at this point actually include some sort of PDF viewing, but more interactive PDF experience is not supported by default in web browsers, which is kind of interesting because between web browsers and PDFs, you got two most popular desktop pieces of software out there. We know the cloud storage providers, Box, Dropbox, and all of those guys actually do support some basic reading and maybe some even basic interaction, but it is still, there's still a lot to be desired. And we know that Adobe tools or Nitro tools actually provide a lot of productivity that is still not commonplace elsewhere. And that productivity hasn't really been commoditized just yet, right? Like we still have to pay for these services. These APIs are not necessarily free. There's a lot of power that is still not free for all, or it is not commonplace. So it is still somewhat cumbersome and expensive for the power user. And so that's been 22 years in the making, similarly how long internet's been around as well in the current shape or form. And so if you might question me, and I hope that we can have a debate about this and we can talk about what we can do here, that if it's taken us 22 years to get to where we are today with PDF productivity and it's still not commonplace, is there hope that we can evolve past just plain PDF productivity and into understanding PDFs? I think there is. I'd like your help with that as well, and so that's what I'm going to be talking today about this presentation. And in these last 22 years, with the explosion of smart devices and mobile workflows, with data volume explosions, streaming data requirements, high uptime and performance expectations, right? Like right now, you tweet something and people can retweet it or see it within literally microseconds anywhere around the globe. So distributed, interconnected global systems, multi-core processors and all of these things like that, like our complexities have really, really evolved. And how much data we're consuming, even just to look at amount of data on the internet, if that was actually something you could query, it's just exploding. And so it is not a static problem, right? Like we're not dealing against something that is static. We know that this is getting more and more complex by the day. And it might appear like we're losing a bit of a battle here. Like we are still struggling to make PDF productivity commonplace, yet PDFs are exploding in their popularity. And we're not necessarily doing much just yet to understand them at scale. So therefore, there's a huge opportunity, hopefully, for this. And so what do I mean by understanding PDFs at scale? And so here I'm just going to talk about maybe two use cases, maybe just plain open World Wide Web, and maybe proprietary enterprise needs. And for enterprises, there's a growing need to understand documents a lot better, to make that understanding and workflow and document management a lot more automated, a lot more efficient, because the number of documents per worker is growing, ever growing. And while we are doing that, we are also somehow supposed to be able to deal with exploding information growth, which is literally happening everywhere else in the enterprise. And so we get to the point, well, okay, so what does it really then potentially look like to understand PDF at web scale? And what would be the components in understanding that? So this is a very simplistic overview. This is limited time. We can talk about this for a long time. But just to break it up in several distinct, maybe, processes, let's imagine that we were trying to understand all the HTML that exists on internet. We'd probably need to first crawl somehow, somewhat to the internet. We would need to extract the content, both hierarchically as well as linked it, to understand individual pages on their own, as well as how they are linked together in the overall corpus, or not linked. Then understand relation and influence. And then in the end, we might be able to, once we do all of that, we might be able, like Google, to offer a business product like Google AdWords, which might be itself, worth multiple billions of dollars in every year in the marketplace. So when you map that to the PDF, the first problem then is, okay, so we need to ingest PDF. We then need to extract content from it. We need to understand it, and then potentially might get to offering insights. But let's talk about the first three really just quickly. So PDF crawling and ingestion. So it happens so that web crawling algorithms have been around and studied since the dawn of time and since the dawn of internet. And they are a fairly well-studied, well-understood set of problems, not meaning that they are simple to implement or simple to design and execute at scale. But if you just do a Google Scholar paper search for this string web crawling algorithms, you get 153 distinct papers that go into depth about how you might go about implementing something. If you also do a very naive, this is super naive stuff, right? Like I'm just trying to map the size of the problem and what might be out there. If you do again, just a Google search for PDF file type, you get 1.5 billion PDFs, right? So you're like, all right, so super naively, how do I actually enumerate all of these guys, and how do I apply some of the web crawling algorithms to this, right? Which is naive, but actually that's how most algorithms work. We know that from even simple counting like MapReduce things, even the simplest of math operations, which is addition or counting, is really perturbed by the size and the distribution of the data set, right? So like actually implementing a distributed counter via MapReduce is not simple. So it might be a naive approach, but doing it at large is really, really, really complicated. And then if you're potentially one of these customers on top of Dropbox or Dropbox itself, given that more than a couple of billion net new files flow through the system on a daily basis, just roughly speaking about how many of those might be PDFs, we're talking about 10 million, 100 million PDFs. So we're talking a large. Either you're crawling web or you're crawling, some large enterprise. And we have our own enterprise customers where people are talking about generating 1 billion PDFs per year. A lot of these are machine generated, by the way, right? Not just humans entering forms or editing in Acrobat or Nitro.
So Dropbox actually announced last week that they have 18 million PDFs in their repository. I'm sorry.
Billion.
Billion.
So that's why I extrapolated this off of.
But it was. We actually have a number, which is interesting that they made that announcement.
Yeah. Which is where I extrapolated, kind of like net new. What are they doing? If you're just scared about, I'm going to get the net new. The interesting thing there is like how many are duplicates, right? Which is then another problem. All right, so we have 18 billion. How many are duplicates? How many of those are W4 forms? Right? And you technically need only one, and then you need to reference it, and so forth and so forth. But again, this is super naive. I'm just trying to give a file ingestion, file document value creation pipeline in understanding content from PDFs. This is all very, very naive. But by the end of the presentation, I hope you will understand that there are many, many building blocks here. And each one of these building blocks is super complex in itself, even though it might be a naive approach to it. So perceivably, if you have somehow figured out your distributed system architecture, which in itself is a difficult piece, in order to consume or ingest this many PDF documents either per day or continuously being streamed from your customer base or the internet, and let's just assume that that has been taken care of. Now, the next step that you would need to do is PDF content creation. And there were already a number of great talks today, and I think there's going to be some tomorrow as well, where everything from even just extracting text from the PDF happens to be a non-trivial problem. We know, actually, that's in the next slide. So just thinking about extracting PDF content is we have fixed layout, unstructured data somehow locked in a PDF file. And I mean unstructured because tables are not preserved as tables. Forms necessarily may or may not be described as a certain type of a form or not. Again, because there are many different PDF creation software out there, so you don't know what you're actually dealing with. And when you have a PDF, you need to extract natural language. So starting with like characters, building words, sentences, paragraphs. When you have that, you also then need to care about hierarchy, content hierarchy, meaning what is a table and what is the header or the footer for that table, what is a header and a footer for that document and that carries around the entire document. Like this background, you might want to abstract that from the actual natural language understanding of the document, this orange Nitro background. Content markup is another thing that is very, very difficult as well, resolving font sizes, font types, and understanding what those really actually mean and how you might represent those. So there are 3 ways that you might go about this, hypothetically, and there's potentially multiple others, but I just broken down into 3 high-level approaches. First one that I'm referencing here is algorithmic or mathematical. A quick shout out to one of our research engineers, Malcolm, who is presenting tomorrow on how you might go about table cell extraction from a PDF document. So these are highly predefined algorithmic steps that you can engage, as opposed to following a number of heuristics or rules-based approaches to kind of know this is kind of the best typical outcome I can expect when I'm analyzing a table. So this is how I'm going to draw a bounding box around the table, for example, because off of what I've learned so far in a heuristic I've built. At Nitro, we call it the art of PDF processing because it's somewhere between a craft and a science, and it takes a lot of practice, so we just call it the art. And the third part that you might want to do is kind of different to both of these is machine learning. And so you might somehow, if you have a PDF that you can understand, process it through various machine learning algorithms for various needs. For example, you might want to classify that this document is actually a presentation. You should be able to recognize that. Versus you might want to classify that this document has to do a lot with www and PDF acronyms. Those are different problems, complex problems, but they're very different than the previous two. So why is this challenging? I kind of alluded already to this, because there are many different PDF creation libraries out there, PDF writers out there. We know from our Nitro document corpus and database that about 10% or more of PDFs are actually not properly formatted or formed, and they might be missing data for reproduction. And so feeding all the data that was missed, or understanding how to go from some sort of a glyph to a Unicode is actually not a trivial problem. When you're dealing, for example, with forms, whether they're most likely the form that you're dealing with is not an acro form or is not even an XFA form. It has been somehow created, most likely in Word document, and it was printed to PDF or somehow obscured by Mac Preview. So you have to be able to understand all of these different pieces, and you're dealing with an explosion of possibilities. Of course, if the PDF itself is image-based, then you need to first of all figure out how to run OCR on it. At scale, very, very difficult problem. And what is then really interesting that as you start dealing with scale, when you start carrying around all the metadata in a PDF, that might become really, really expensive. So for example, let's just assume that for every word or paragraph you were extracted, you also wanted to keep information around the page number, orientation, font description, and all of those things. Literally, the volume of data explodes. So at Nitro, for some of our own purposes, we basically get a 10x byte size explosion between the original PDF document and the actual extraction that we get from it and what we want to actually work with. It's kind of a really interesting issue. Again, at scale, that might not be a problem if you're analyzing a couple of hundred or maybe even a couple of million documents in a fixed model. But when you're doing that at scale, at streaming, that becomes a really interesting challenge that perturbs with scale. So another thing that you might have to then deal with is now at scale, you can't do everything in memory, obviously. And whatever you're doing today, there's going to be a smarter person coming next year or next day on your team who's going to want to do something different to the corpus that you have. And so you're dealing with versioning, you're dealing with serializing the data, storing it and retrieving it. You're dealing with distribution problems. So there are a number of solutions out there for that. Everything from Apache Thrift to Google Protobuf. But if you really care about schema, and if you really care about optimizing for read rather than write, you're probably looking at some of the formats that are supported natively by Hadoop, since presumably you're doing some analysis at large scale, distributed scale like that. So you're looking at Avro, you're looking at Parquet. The reason why I have this slide here is because even going from an in-memory representation of a PDF that somehow you were able to extract to storing it so you can recall it later on, serialize it, distribute it, work with it, is actually a non-trivial challenge itself again. So any one of these things that might be really trivial, for example, if you are just working with a number of files on your desktop or even in some repo, becomes really difficult at scale, at distributed scale, or when you need to recall something in past. Again, fun challenges, lots of stuff to resolve here. So you somehow are able to capture PDFs. You somehow are able to extract content from them. You are able to deal with all the edge cases that happen with malformed PDFs. Then you're able to serialize and write that data. You're able to actually properly label it so you can understand the schema when you're recalling it later on, when you're processing it, when you're dealing with it. And then you're finally getting to the point which is getting you close to the goal, which is now I want to understand this content. So far I've been just extracting it and saving it. Now I want to understand it. And again, maybe there are three different approaches that you might take. You might want to take an algorithmic approach, a heuristics kind of rules-based, based off of best known practices approach, and then you might do various machine learning approaches. On the algorithmic side, I think Malcolm is briefly tomorrow going to explain how you might take extracted tabular data and turn that into something that is relational, because once you have rows and columns, you can actually start describing the data. And you might actually have relational interfaces into querying the data for questions. On the heuristic side, you might be doing various things to actually, again, if it is not an acroform, if it's not an XFA, you're trying to figure out, okay, I know that there is a box here. What is this box about? So you might be doing kind of based off of your own corpus and say 100,000 form PDFs that you have, analyze what are the precursors, leading words before a box that describe that box. So you might actually then build a whole bunch of rules regarding that. Again, not a trivial problem at all, and one that has to have a really large label data set that you can test against. And, or, differently, you might apply a machine learning solution to this. So if there's a Leonard Rosenthal mentioned in a PDF document, you might want to then try to understand, well, I know that this is a name, but how do I resolve this name? Like, to really understand something, you need to be able to, at least resolve it and map it to something, right? So now you know this is a name, because somehow you have first and last name somewhere. Second of all, how do I resolve this? So maybe you crawl the internet, again, somehow, somewhere, he's PDF architect at Adobe, associated with PDF Association, or if it's a business, you might be connecting to an HRIS system, so at Adobe, we would know what his employee ID is. Again, to do something that is worth doing, it is really difficult, because you need to follow this chain of indirect hops to get to understanding content in a document. But first, obviously, the problem is get the content in a form that you can understand. And as I kind of hinted at that as well, although understanding is like this holy grail, it is actually a lot more expensive and more difficult than just text extraction itself. It is a completely different problem as well. Some of the solutions that you have for PDF content extraction might not map to solutions that you have for understanding the document. Some of the basic understanding might be done during the extraction as well. But again, because it is more expensive, you have to do something batch. You have to do something after the fact, which is then really, really interesting. And your understanding will evolve over time. If in the beginning all you want to do is, for example, query all the PDFs that you have and extract your employee names and who is mentioned where, that's one thing. But later on, if you want to do something again, you have to have the data serialized so you can do it again and again. So this is just like a really quick high-level overview of following these postulates of, understanding is more expensive than extraction. Basic understanding potentially might be done at extraction level. That you might then have batch processes where you're kind of rerunning your results and then serving them. This is how you might section it off. Lots of detail here. This is a reference architecture at a high level. But what is interesting to just point out is that we do rasterization and extraction of words and entities and paragraphs somewhat in real time, whereas all the other understanding is really actually done, large-scale analysis is done in batch and in a clustered environment, right? But it is the same code, and it is the same underlying messaging system that we are working with. So going from a service layer to a pipeline layer, going from real-time to batched, this is kind of some of the things that we are doing at Nitro to think about this. Thing to point out here is that obviously, because this is scale, you will need You will need to have various data stores. You will need to have various file formats to which you are writing and serializing, way to call them up, way to distribute them, way to understand how do they relate to one another, and a way to get immediate results back to the customer. When they, for example, upload a PDF, you want to give them something back immediately, say it's a rasterized version of a page, versus understanding over maybe a few minutes or whenever it is what the page is really about. Again, fun problems at scale. So potential insights, this is up for anybody's, I hope I sparked your imagination here to both kind of how important this might be and how difficult it is actually to achieve. Some of the things we might do, say we're starting a company tomorrow and we're saying like, we're going to be Google for PDF, right? Don't know exactly how well Google does this right now, but you could then, if you were processing PDF at web scale, you might be able to offer better recall information that is locked currently in PDFs. Like Google search engine works really well for web pages, not so much necessarily for PDFs. It does and doesn't. It's getting better. You might be able to just like Wolfram Alpha answers questions about math. You might be able to answer questions to queries off of structured data in documents that are in PDF, either on web or something that's really specific to your business. Pattern recognition is really key and important. We were talking about W4 is most popular, probably single PDF out there on the internet. But if every time you upload a W4 to a system, you were able to classify it and recognize it, you necessarily wouldn't need to store a net new copy of it. You might be able to look at what version it was, how it was versioned, whether it's the right version as well, whether or not it was filled out or saved or anything like that. And then understand deviations off of it, assuming that was a W4 they filled out for various employers or various years, seeing how it changed over time might be really, really interesting as well. Applications are endless. What I hope that this quickly showed is that number one, doing anything at web scale, we know that is really, really difficult, since even the counting is really perturbed by scale. But especially understanding PDFs at scale is something that is super complex. And for that, I don't think that any given company, any one particular company, has a shot of doing it purely on their own. And in case you were not already convinced that open source is in the world, here's some of the latest numbers. There's an annual open source survey. These numbers, I think, are pretty convincing because most of the companies, three-quarters of the companies run in open source, 2/3 of companies are participating in open source, and more than half of the engineers said they're somehow working on it or dealing with it. And so, as I said, don't think that the problems of this magnitude can be solved only within a single team or within a single company. There are multiple problems, and they're actually quite different. And algorithms or solutions that you would have for ingesting PDF at scale are completely different than dealing with PDF content extraction, which are then completely different than understanding PDF, which are then completely different than actually serving business insights and potentially monetizing it that way. So, Leonard is here as well. So I hope that this is something that we can talk about at the PDF Association level as well. But how do we work better together as an open source community? And how do we start sharing some of these lessons learned so not that everybody has to reproduce them? Matter of fact, at Nitro we have a really large push for open source. Some of the things that we are going to be open sourcing very soon are behind github.com/nitro. Some of the stuff that Malcolm's going to be presenting tomorrow is going to find its way there over the next following months. We are very happy to take any questions and any collaboration requests. We're working with a number of research universities as well, and we're hoping that some of these algorithms which are very specific to a part of the overall problem set, we can actually share with a wider audience. Thank you very much. Happy to ask any questions. You don't have to all rush. Yes.
What currently is up on your GitHub right now?
We're about to...
The S3 client that
yeah.
Greg did.
Yeah, so, good point. So we talked about this part, web crawling. So we open sourced S3 client, so we use AWS S3 as a document store, both for, especially for processed or post-processed files. And so when you have buckets that have literally billions of files in them, it is completely non-trivial to actually iterate through them, count them up, figure out what might be duplicates or bad data or anything like that. And so we're a functional Scala shop as well. So we wrote this function library, which Malcolm contributed to as well, in Scala for iterating. It's called S3 iteratees.
Yeah.
We changed the name.
I think that's the name.
That's the name, yeah. You can look it up. It's referenced over there. We are trying to, for each one of these, actually open source some of the bits that we've learned. Actually, for the content extraction, as I said, Malcolm is talking about that tomorrow. We're going to be open sourcing part of that as well very soon. And for understanding, we're going to be making some announcements in the new year, not to preface it, but we're right now working on a couple of research universities to partner and discuss what we're doing with machine learning and how it applies to content understanding. Again, we're trying to do bits of everything to showcase what is the challenge and what is the opportunity as well. And we're trying to do that in an open manner as much as possible so that we invite collaboration.
You mentioned web crawling. Are you guys web crawling from the software lab, or are you making a product for third parties?
No, we're not, actually. I just mentioned that because it is similar, for example, to the problem that we are interested in, which is indexing all of the business documents. In that case, it's slightly different because you need to have connectors to various data stores and data types. Web is kind of simpler, not at all, actually. It's more difficult because of scale, but simpler because you can just go off and look at one of these algorithms and start doing it yourself. Some of our team members worked at a company called Cloud, which was acquired by Lithium, and they did basically web scale live stream ingestion from Twitter and Facebook, every tweet and every post that was public. And so we're very much interested in this large-scale, web-scale ingestion of data. Both kind of crawling and ingestion are a bit potentially same part of the pipeline.
You talked about it at the beginning, but can you take me through again what the opportunity is that you see that occurs when this is possible?
Yeah. So I think when you know, back 22 years ago, you know, 92, 93, when or later on when Google released their search engine, I didn't think anybody at that moment could predict that AdSense was going to be, you know, whatever it is. I don't know how many $1 billion per year it is right now, but it's insanely big. There is a tremendous opportunity for anybody who is able to even glimpse at how the web is ordered or how it's structured, right? And then can offer insights to businesses, to end users, right? So I think that's what we saw at Google. I'm not saying that we're in the web crawling PDF space at all, but I'm trying to use a similar metaphor, something that all of us use on a daily basis, and that, you know, 20 years ago when I saw it, I could have never predicted that this was going to take place. And even when Google went IPO, nobody could have predicted that it was going to continue to grow and going to continue to still be the largest part of their business today. So I think possibilities are really up to us, right, and up to the users. Another thing that you might argue is that, well, let's just say that there were APIs that were already readily available for this. Given how many there are PDF API or SDK or app solutions companies, I'm assuming that a bunch of them would jump on the opportunity. If this was doable right now.
So, what's the main challenge of PDF at scale? It seems, I mean, there's like many aspects of, you know, accessing and indexing PDF at scale, but what is the core of the problem?
I tried to split it up into these three, and I think they're all equally difficult and equally challenging, and they require different solutions to them. assuming that you were somehow already had the PDFs and you somehow were already able to extract all the content and label it in the right way. Understanding currently right now is just the holy grail for what's happening in the machine learning insights-driven economy out there. So, you know, say IBM just announced, or maybe a month ago or so, announced the Spark Technology Center. So this is their third technology center after Linux and Java. So they're betting really hard on Spark, and Spark is based on next generation Hadoop. So really in their MLlib libraries, they're really productizing machine learning and bringing it out to the masses. Like they want to train 1 million people on machine learning on Spark over the next whatever years. So assuming these two things were already solved, which they're not actually for PDF, for HTML they might be, for PDF they're not. The third thing is like, you know, it's holy grail for anybody working in machine learning right now.
So I have two questions. The first one was more a technical one. Do you see kind of the supervised or unsupervised machine learning? Where do you see the value there between the two?
Yeah, that's actually a great question, because actually even from PDF Sean, I think he's tomorrow talking about, if I'm going to butcher it, I apologize, about semantic understanding of PDF content. And we were just talking about the need to have large labeled PDF data sets, which are really needed for multiple things. They're needed for the community, so we can all talk about our algorithms. Even if we're talking, if we're keeping implementation of algorithms close to our chest, we might have like ImageNet-like competitions out there on Kaggle, right? Which Facebook and Google and all these other companies, which are really keeping their implementations proprietary, are actually entering and sharing the best practices. Right? Like MapReduce came out from some of these kind of efforts, not necessarily directly, but similar to that. So like what Kaggle has done for some of this stuff is really interesting, and we're missing right now large labeled public PDF corpuses. So that's really needed for supervised.
Yeah.
And so your question is, what is more important, supervised or unsupervised? Or
yeah, well, where do you see that there being a greater shift towards all that kind of? I mean, obviously you want like a good corpus, like you said, and I think that's. Are you guys building that? Is that something you're working on?
Yeah, we'd love to collaborate on that with anybody who's willing to help out. Because of how obscure some of the data is in PDFs right now, like, given that it's unstructured, and most of the businesses actually don't share their PDFs, even if they're scrubbed. I think that we still don't even know the possibilities of understanding PDFs if we actually had public available, well annotated, labeled, large PDF corpuses. So my bet would be unsupervised. But then again, like let's say Netflix open Kaggle competition about best predictive algorithms for best recommendation algorithms for movie viewers. Like they had to open source their label data set.
I'll just, if you don't mind, I'll comment about the question that was asked Evan earlier, which is in terms of, what's sort of the hardest. And I'm going to talk a little bit about this tomorrow, and I think Phil is at the keynote. But one of the things that's interesting that we don't always think about when we look at web scale, PDF, HTML, is every HTML page is one page. Mm-hmm. When we think about PDFs, we've got documents that are hundreds, thousands, millions of pages. And when you talk about ingestion and a lot of the things you're talking about, trying to potentially process a 1 million-page document, which is not an unreasonable thing, at scale becomes a very different problem than a single page or even a 10-page document.
That's right.
At scale.
So at scale, everything is perturbed. You're right. So
and it's a very different problem to split out. I mean, you talk about Spark as a great technology, and it knows how to do multiple documents, but it doesn't do well to take a document and split it across multiple Spark processes or similar things.
Yeah, so that's some of the plumbing that we have to write ourselves, right? So high availability, like any of these things that you have a distributed online system, are going to become its own beast, its own challenge. That's why this problem is also fun, because working PDFs was already, an interesting problem in and of itself, but now that you put it online in a distributed fashion and start thinking about understanding it, has all these new facets to it. That's why we're kind of excited as engineers at Nitro. Any other questions, comments? Well, thank you guys for your attention.
Thank you.